All right, guys, so our warm-up, we just wanted to plot a triangle ABC, and it gave us the coordinates. So let's go ahead and plot those coordinates. So let's plot A, which is at -2, 2. I'll use red for this first one, and I'll use blue for the second one. Okay, so A is at -2, 2. That's right here. Label that A. B is going to be at -4, -2. That's down here. That's B. And then C is at -1, 1. That's right here. That'll be C. So this is a triangle, so we're just going to connect all three of these. Next, we've got A prime, which is at -2, 0. A prime. B prime is at -4, -4. It's down here. And then C prime is -1, -3. And if you can see that, all of the points were just shifted down 2 spaces. So A was shifted down 2 spaces to get to A prime. C was shifted down 2 spaces to get to C prime. And B was shifted down 2 spaces to get to B prime. So the shift we can represent by this green arrow, 2 spaces, 2 spaces, 2 spaces. And what we're going to learn today is we're going to learn all about these shifts, okay? Now, the shifts may not be just 2 spaces down like we just did. Some of them might be a combination of things, but what this is called a transformation, and specifically it's a translation. That's when we're moving an image around the coordinate plane, okay? All right. So this is chapter 4, section 1, translations. And you can find this in the book on page 173. Okay, so we're going to start off by defining what a vector is. A vector is a quantity that has both direction and magnitude, or size, and it is represented in the coordinate plane by an arrow drawn from one point to another. Here is our vector. We're going to label this vector P. We're going to label it PQ, okay? So this is how we write it. So it starts at point P and it ends at point Q. So we have to write it in this order. Now before, when we were dealing with lines, we could write it in either order, right? We could write it QP or we could write it PQ. In this case, it has to start from the base and it has to go in that direction, okay? And then how we actually write on top, normally we would draw a line, right? But for vectors, what we do is we draw the base of the line and just a top arrow, right? So it's not the full arrowhead. That distinguishes between a vector. Because remember, if this were array, right, this would go on forever, right? But in terms of a vector, it stops. Now, it has to have the arrowhead because it has to show us what direction it's moving. Because remember, vectors have magnitude, so size and direction. But it does stop. So it stops at 5 units to the right and 3 units up. It does not go on forever. So that's the difference between a vector and array. All right, the component form of a vector. So all we're going to do is your component form. So PQ as a vector, is going to be, now notice it's not a parentheses. It almost looks like a less than sign, but that's how we write the component form. Is going to be the change in the x direction, which is just 5, or how many units to the right, and then 3 units up. And we write it like that. So this is what our PQ looks like. So this first 5, you guys make sure that you recognize this is our horizontal component. And then the blue is our vertical component. All right. And that's what's called component form. Okay, name the vector and its component. So this vector, again, this one starts in at P, because that's the base, and it moves towards Q. So we're going to put P, Q, and it is a vector, so we have to put our modified arrow on top, okay? Now, how many units did how many units did we move in order to get from P to Q? Well, let's figure out our horizontal component. We moved 1, 2, 3, 4 units to the left. So this is going to be -4. -4. And then we moved 1, 2, 3, 4, 5 units up. So this is going to be +5 or just +5. So 5 units up. This is how we write this vector in component form. -4, 5. Okay? It's very similar to the slope. So the slope of this vector would have been 5 over -4. Remember, rise over run? Or just -5 over 4. Okay? All right, transformation. So let's go ahead and talk about our first transformation. A transformation is a function that moves or changes a figure in some way to produce a new figure called an image. And the first one we're going to learn about are translations. Oops. So transformations is like this general term just saying like we're moving figures around, we're changing their images, we're producing a new figure, okay? And translations is just when you're moving an image from one place to another. So just like we did in our warm-up, right? Where we were moving points around in order to change the image. Same thing happens here. So to go from P, which is at x1, y1, to go to P prime, we're going to add A to the horizontal component and B to the vertical component. So we're just adding a vector AB, right? Or in component form, it's AB. Same thing with Q. We're going to move it the same amount, okay? A translation, you have to move all of the points the same distance. That way you don't actually change the image, okay? Notice how this line segment is the exact same here as it is here, okay? It's just shifted in our graph. All right, the vertices of A, B, C are A at 0, 3, B at 2, 4, and C at 1, 0. We're gonna translate A, B, C using the vector 5, -1, okay? So let's go ahead and plot it. A is at 0, 3. That's A. B is at 2, 4. That's right up here. That's B. And C is at 1, 0. Over 1, up 0. This is C. So if we connected all of these dots, we would get a triangle. And it wants us to shift this triangle 5 units to the right and 1 unit up, okay? We're going to apply this vector to this image, okay? So we're going to go from here, from C, we're going to go 5 units to the right, 1, 2, 3, 4, 5, and down 1 unit, okay? So this will be C prime. B will go 1, 2, 3, 4, 5, down 1 unit. This will be B prime. And A, we're going to go 1, 2, 3, 4, 5, and 1 unit down. So this will be our new A prime, okay? So our image looks like this, okay? And you can get an idea if you did it the right way, because it'll look exactly the same, just shifted. And if we draw arrows from all of our original points to our new points, okay? These arrows are the vector that we just shifted, right? All of these arrows are 5, -1, okay, as a vector in component form. And our image looks the same, it's just shifted, so we are good. All right? Okay, now we're gonna write a rule for the translation of A, B, C to A prime, B prime, and C prime. Okay, so really guys, all you need to do for these is find where your original A was, which is here, and draw a vector ending at the new A. So here, and remember we moved in this direction. You always go from A to A prime, unless it states otherwise. And in this case, we moved over 1, 2, 3, 4 units, and then up 1. So we actually, the vector form is going to be -4, 1. Okay? This is what's called our translation. So our translation is -4, 1. Okay? And you can always check that by doing it with another point. So let's take C. Let's check it with C. C, we moved over 1, 2, 3, 4, and up 1. So same thing, -4, 1. C is the same. Okay? And B prime would be the same as well. All right, but in reality, guys, again, with translations, you're not moving the points different amounts. You're moving everything. You're shifting the entire image the same amount. So if you just found 1 point, you'd be good to go. It's always good to check, though, if you did it right. Okay, a composition, right? So we learned about translations. A composition is a combination of at least 2 transformations. In this case, we only know about translations. So in the graph, RS with endpoints R and S is an image and its image after the composition. So our translation is we're going to add 5 in the X direction and we're going to subtract 2 in the horizontal direction. Then our second translation is we're going to go back 4 in the horizontal direction and we're going to go down 2 more in the Y direction. Okay? So this is what it looks like. This is our original, right? Let's just take this translation, which is x plus 5, y minus 2. Let's write that in vector form, which would be 5, positive 5, minus 2. So we're going to go over 5, 1, 2, 3, 4, 5, and down 2, 2. Okay? See how that matches up? Now we're at S prime. S double prime, we're going to move down 4 and down 2. Or in vector form, -4, -2. So let's move to the left 4, 1, 2, 3, 4, and let's move down 2, 1, 2. And we're going to end up at S double prime. Okay? So we've got 2 vectors here. Our first one, which is right here, is 5, -2. That's this one. And our second one here is -4, -2. Okay? So that's what's called a composition. We just moved our image twice. All right? Okay, now we're going to try a composition of our own. So we're going to graph RS with endpoints R at -8, 5 and S at -6, 8. So R is at -8, 5. That's -8, 5 is up here, right like this. Okay, and this is going to be R, and S is going to be at -6, 8. That's right here. So RS, and it's a line segment, okay? What we're doing with this line segment is we are translating it twice. So we're going to have 2 different images after this. So let's do our first one in blue. We want to move down or to the left 1 and then up 4. So let's move to the left 1 and then up 1, 2, 3, 4. This is going to be S prime, okay? And then R, we're going to move to the same thing, to the left 1 and then up 1, 2, 3, 4. This is going to be R prime. Now, it does get a little confusing when I draw, so I'm going to erase the lines that I drew, okay? But just wanted to show you guys how we were getting to these points. Oops. Okay. From here, I want to connect these 2 to give us our new line segment, okay? Our second translation, we're going to move 4 to the right and down 6. So S prime is going to move 4 to the right, 1, 2, 3, 4, and then down 6. 1, 2, 3, 4, 5, 6. This is what we call S double prime, okay? And R is also going to move 4 to the right. 1, 2, 3, 4, and down 6. 1, 2, 3, 4, 5, 6. This will be R double prime. So S double prime and R double prime. That's it. This is our final image. Okay? So guys, really realistically, all we learned today are translations, and one thing that I didn't really go over was that this is how translations are written in terms of a rule. Okay? So you just write like X, we're going to subtract 1 from that coordinate, and then we're going to add 4 in the Y direction. You can also write it as a vector. So remember how we were figuring out what the rule was? If we were to draw a vector from S to S prime, that vector is going to match with the translation that we did. So in this case, this one's moving to the left 1, and then we're moving up 4. So this is going to be -1, 4. And then in this case, that directly matches up with what we wrote for the rule. Okay? Here's your homework. It's 3 through 21 odd. Good luck. Let me know if you have any questions.